Our lecture today is on the area of sleep. This is lecture number 19. And I think that this is a great area because its application um, uh, and relevance to what we go through every single day. Um, these periods of our life in which we are sleeping for approximately a third of a day, but we don't really know too much about what happens during that period of time to us physiologically and behaviorally. I think it's an area of study that was neglected for such a long period of time, but then when the EEG machine became available and we started using it on a regular basis to take a look at electrical activity of the brain, we'll be discussing that research that helped us tremendously to be able to understand what is happening during sleep. So again, with that in mind, let's begin our analysis by talking about what I call important facts about sleep. We spend 30 to 40% of our life of our lives in sleep, and this the statistic never ceases to amaze me that in spite of that, it's only been relatively recently that psychologists have been able to understand sleep. So again, with that in mind, the relative unknown about this aspect of human existence is it has become increasingly important and studied more. Um, we don't get enough of it, and indeed that is something that absolutely plagues young people, adolescents, many of you who are taking this class. And I guess part of this lecture is to try to convince you that you need to get more sleep in order for you to be healthy. So that's something that we'll be talking about as we go along as well. The other thing is that I try to emphasize is that, in many cultures, I won't say many, some cultures, certainly our own, not having enough sleep is viewed as a badge of honor. Um, I cannot tell you how many times I've heard people say sleep is for losers. And nothing could be further from the truth. You are doing such harm to yourself um, in terms of your behavior, in terms of your health, in terms of your physiology, if you do not get enough sleep. And lastly, I want you to think about this for a few moments. We're immobile and we're unconscious every single day, while we're sleeping for somewhere, between 7 to 9 hours. We are incredibly vulnerable. Somebody could do great damage to you very rapidly, and you would simply have no time to respond. Why is it that evolution put us at such a disadvantage? A disadvantage, yes, a very profound disadvantage, because again, many terrible things could happen to you during that time. But think about it. If evolution has done this to us, there must be meaning to it. And the meaning to it is this: sleep is so important that you're being put at this disadvantage, this vulnerability every single day. And it's because sleep is so critically important for you. Okay, so let's take a look at that then. Uh, in light of these various facts that I've noted to you, let's talk a little bit more about some of the work that happened in the area of sleep. If we go back into the early 1960s, there were some really interesting studies that were done over in Soviet Union by scientists there, physiologists and psychologists, in which they kept experimental rats awake for a number of days on end. And the way in which they did this was whenever they saw that the rat was starting to fall asleep, starting to close its eyes, they would pinch its tail. And that would keep the rat awake. And indeed, what happened was that keeping them awake, after just a 5-day period of time, some of the rats started to die. So that's how essential sleep is. It's as essential as food. It's as essential as water for survival. So here's a wonderful researcher um, by the name of Matthew Walker. Was at Harvard Medical School, and he wrote a book, actually just fairly recently, called Why We Sleep. And it is a really interesting read, and it's something, for the average layman. And I highly encourage you to take a look at it. I think that it would help you to understand even better some of the research that's been done in this area. But here's one of the things that Walker has been exploring. What happens to your memory capabilities, for example, just with a single night of loss of sleep. And one of the things that we know is subjects are about 40% worse off in terms of memorizing lists of words when they have not had a full night of sleep. One night of good sleep actually improves memory. So if you get a night of, let's say 8 hours solid sleep, that's actually going to help you in terms of memory processing. So one of the things that we know is that practice certainly is important. Certainly reinforced practice is critical in terms of memory processing, but with a night of sleep, that makes perfect. One of the things I tell students is one of the worst things that you can do in preparing for an exam is failure to get a good night's sleep on the night before the exam. And again, experiment after experiment after experiment after experiment that's been done in the field of psychology proves this. What if you sleep, but you just don't get enough sleep? Here's one researcher, David Dinges at the University of Pennsylvania, that's been studying this by using a technique which is called chronic partial sleep deprivation. And here's what he does with these human subjects. He keeps them awake till about 4 a.m. and then he arouses them about 8 a.m. They get about 4 hours of sleep a night. Okay, so this is chronic partial sleep deprivation, night after night after night after night. And what he finds is that all of these aspects of behavior are impaired. Your ability to attend and focus on something, your memory processing, the speed of your thinking, your alertness, your reaction time. And indeed, one of the things that he notices is that, okay, these things are impaired after just one night, but after 2 nights they're even more impaired. And after 3 nights, they're even more impaired. And after 4 nights, it's even more impaired. So each day that you don't get a full night of sleep, this accumulates. Okay. And what is being impaired is all these different aspects of our behavior. Many of you may be familiar with this phenomenon, which is referred to as microsleeping, in which an individual riding in their car, for example, haven't gotten enough sleep, and they start to fall asleep, start to nod off, and it only takes a fraction of a second to go off the road, hit a tree, or to go over into another lane. And many people think that if they are tired, for example, while they are driving, they can slap their face and that'll be helpful, or turn the radio up, or roll their window down so they're getting a breeze on their face. All of these things, are not helpful. They're not going to prevent you from engaging in this microsleeping. So, this is a problem. One of the major causes of accidents today is people that don't get enough sleep. So there have been some world famous accidents due to sleep impairment. The terrible environmental uh, um, compromise that took place with the Exxon Valdez oil spill a number of years ago, in which essentially a captain fell asleep and the boat ran aground, and oil from this oil tanker spilled all over the Alaskan coast. and we're still paying the price for that in terms of environmental cleanup. Chernobyl and the nuclear meltdown in Chernobyl was certainly another case of, if you take a look at records that were maintained by the management team at Chernobyl, there's a very strong record of individuals there on that management team that weren't getting enough sleep and were probably chronically sleep deprived. The 3 Mile Island disaster near nuclear meltdown in Pennsylvania a number of years ago. This too, if you examine the records, if you examine the diaries, the logs of the individuals that were on that management team at that time, they were not getting enough sleep. The Staten Island ferry crash, in which I think 12 individuals were killed and somewhere around 20 or so injured. Captain fell asleep. And indeed, when he fell asleep, he rammed the Staten Island ferry into a pier. And again, this loss of life that occurred. So again, case after case after case of these incidents due to sleep impairment. So here's what we're getting now. According to a 1960 study, the average is about 8 hours of sleep. In 2010, the average was down to about 6.7. I don't know what it is now as of 2020, but we're trending in a very bad direction of simply not getting enough sleep. Less sleep is, without question, associated with a lot of health problems. This endocrinologist at the University of Chicago Medical School, Eva Van Cotter, has been doing some wonderful research showing that if you use that chronic partial sleep deprivation tactic that was used by David Ninjas, you enter a pre-diabetic state in about 6 days of partial sleep deprivation. And one of the things that we know is that subjects become hyperphagic. That is, they overeat during that sleep deprivation. There's a drop that occurs in a very essential hormone that we'll learn about when we get to the area of hunger. Drop in leptin levels. And that drop, what it does is it signals individuals to eat. So there's one of the big reasons now for obesity in our culture and other cultures is, the lack of sleep that's causing this change in leptin levels, and for people to become hyperphagic and overeat. We also know from the work of Van Cotter, or even more recent studies, and in addition to the association with obesity, there's a very strong correlation with heart disease as well as stroke. So these are, very important outcomes as a consequence of not getting enough sleep. Lack of sleep affects everything. This is an interesting study that was done by Scott McRobert at St. Joseph's University down in Philadelphia a few years back. These are fruit flies that you see here, a male mating with a female fruit fly. And male fruit flies and females exhibit all this very elaborate courtship behavior in which the male orients towards the female, begins to flap its wing and sing a song, follows the female very closely, then starts to lick the anogenital region of the female, then begins to copulate with the female, and then after that the female rejects the male. Well, if you were to take a male fruit fly and deprive that male fruit fly of sleep, that male fruit fly would not exhibit this very rich display, stereotype display of mating behavior. Indeed, it impairs their mating behavior. So again, I hesitate to make the jump from fruit flies to human beings, but I think that the message here is that you need to get enough sleep because lack of sleep can impair just about everything in terms of our physiological and behavioral process. If you take a look at the research that's been done in this area on the physiology of sleep, we've learned some really important things. What I want to do is I want to go over, some of the basics of EEG recordings. Here are scalp electrodes that you see here. They're going to detect the surface electrical activity of the cortex of the brain. That information is being fed into these amplifiers that you see here. Those amplifiers are going to amplify that is, increase the electrical brain waves from the scalp electrodes. Each electrode corresponds to an ink pen that you see on here. On this EEG machine, the pen deflects whenever there's a change in terms of the current that's being detected from these scalp electrodes. So the pen is going to deflect, it's going to change, and it's going to make a mark on the paper, and the paper is continuously advancing on this printer. So this is what you see here, and this is what the readout actually looks like. This is, EEG recordings from 8 different scalp electrodes. And now we need to understand a little bit about what these brain waves mean. Okay, if you take a look at the basics of brainwave activity, I try to get students to think in terms of 2 different types of brainwaves. We talk about the amplitude of a brainwave, that is, how far does a brainwave deflect from its base. Again, if you take a look at this brainwave pattern that you see here, and if you were to draw a straight line through here, what you would see is that this wave that you see here, there's a lot of deflections that are occurring, but they're not deflecting very far away from that hypothetical line that's been placed through here. Okay. In contrast to what you see here, where there aren't as many deflections, but the deflections are much larger. The amplitude is much larger. Okay. If you take a look at these 2 basic features of brainwave activity, amplitude and frequency, here is a brainwave that we would characterize as being an alpha wave. Here's an alpha wave here as well. You get a lot of deflections per unit of time, right? But those deflections are very low in terms of amplitude. Okay, so this is this is an alpha wave that we see here. These are called high frequency, low amplitude waves. Here is a brain wave of a person that is in sleep. And the brainwave pattern is that of very high amplitude, but low frequency. That is, there aren't as many deflections. So think in terms of, amplitude and frequency in terms of brain waves, and that this basically is the brainwave of a person who is awake, and this one is more characteristic of a person who is asleep. Okay. So back in the 1950s and early 1960s, 2 researchers, William Dement and Nathaniel Kleitman, were the first to really discover the 5 different stages of sleep. And let's take a look at them on this figure that you see here. During stage 1, which is the initial stages of sleep, very light sleep, this represents about 4 to 5% of your sleep cycle. What you see is mostly these alpha type waves, okay, the very high frequency, low amplitude waves. What is happening is your muscle activity is slowing down. Occasionally you're getting muscle twitching during this period of time, but this represents a relatively small portion of your sleep-wake cycle. Stage 2 that you see here, this is really a lot of your sleep cycle, about 45 to 55%. So your breathing and your heart rate is slowing down. There's a decrease that's occurring in terms of your body temperature. So again, this is stage 2. You're still seeing predominantly these alpha waves, but you're starting to get a little bit higher amplitude brain waves. Then stage 3. This is deep sleep. The beginning of it, this is about 4 to 6% of your cycle. And your brain is beginning to generate very slow delta waves. So again, take a look at these more high amplitude waves that are starting to occur here. Okay, and it's interspersed with some alpha, but it's predominantly, the beginnings of these slow delta waves. Stage 4, on the other hand, this is very deep sleep. This is about 12 to 15% of your sleep-wake cycle. And you get this very deep rhythmic breathing that is occurring. And your muscle activity is limited. Your brain is producing these very, very large delta waves. Then what happens is this. Stage 5, certainly the most interesting of all the various stages. It is a stage of sleep that's referred to as paradoxical sleep. This is a rapid eye movement sleep, stage 5. What is happening is your eyeballs start to rapidly sweep back and forth from one side to the other. Okay? And what you get is a brainwave pattern that looks like the person is awake. Again, the very high frequency, low amplitude waves. Your muscle relaxes and your heart rate increases. Your breathing is rapid and very shallow during this period of time. But this is rapid eye movement sleep. And indeed, when Dement and Kleitman woke up individuals during stage 5, they almost always reported very, very vivid dreams. This is when dreaming occurs. One of the things that you may have noticed, for example, is that if you've lost a lot of sleep, maybe pulled some all-nighters for exams or something, when you're given the opportunity to sleep, you dream more. And indeed, one of the things that happens is you try to make up what you've lost, and you try to get into more rapid eye movement, REM sleep, in order to make up what you lost. It's as if it's like an equilibrium, that if you don't have a certain amount of this rapid eye movement sleep, then you're going to try to make it up. So that's the essentials then of the 5 different stages of sleep. And again, this period of time when you're getting this rapid eye movement, we call it REM sleep, is particularly interesting because of its association with dreaming. So one of the things I try to emphasize with students is that your sleep is really occurring in 90-minute cycles. It's not that you fall asleep and then go into deeper and deeper and deeper and deeper sleep, and then all of a sudden you wake up. You go through 90-minute cycles, and REM sleep is called this paradoxical sleep because in many cases it looks like you're awake. Again, if you take a look at the EEG activity, it looks like you're awake, but there are other measures that suggest that you're in very, very deep sleep. Again, extremely difficult to wake people up during this period of time. So REM sleep is dominated by these alpha-like waves. REM sleep is characterized by this incredible mental activity, this dreaming that occurs. We also believe that during this period of time, this is when memories from over the course of the day are being consolidated. And again, lots of production of new proteins during this period of time, new proteins in your brain. So if you disrupt REM sleep, you're going to disrupt that normal equilibrium. And indeed, you try to make up the sleep that you've lost, the REM sleep that you've lost. Again, disrupting, specifically depriving a person of REM sleep, you try to make up what you've lost. Okay. So our conclusions then, after having looked at some of the basics of sleep, sleep is an essential requirement for living. It's like getting enough exercise. It's like eating good. It's like drinking liquids and making sure that you're hydrated. Getting sleep is an absolute requirement for the integrity of behavioral systems and the integrity of your health and physiological systems.